Hello and welcome to this video. Today we are going to talk about the standard ExactFlat workflow. To begin, we are going to use the ExactFlat piece creator to form individual pattern pieces from the 3D faces of this model. We click the piece creator button in the ExactFlat Tools command manager to open up the piece creator. Once open, we can now select individual faces to form different pattern pieces from the 3D model. We are selecting multiple faces here, and all of these faces are going to be sewn together to form a single pattern piece. We also notice that this piece has a red arrow emanating from it, and this red arrow indicates the facing up direction. So if we were to lay this pattern piece flat on a table, this red arrow would be pointing up towards the ceiling. In the cases where this red arrow is not pointing in the right orientation, we can simply click on the arrow to flip the orientation so the pattern piece is now facing the correct up direction. In the case for this model, all the pieces are going to be facing the wrong direction, so instead of clicking on the arrow for every single one, what we can do is we can just toggle the default orientation to flipped. And now every single piece is automatically going to be flipped to the opposite orientation. When creating pattern pieces, we can either click the Create Pieces button here, or we can press Enter on the keyboard to expedite the process. Also, while forming pieces, we can actually select right through pieces that have already been formed, making it easier to select pieces that are hiding behind different layers. Once all our pieces are formed, we click the check mark to close the ExactFlat piece creator. ExactFlat and SolidWorks will knit all these faces together to form surface bodies. If your process already creates surface bodies, then you can skip the piece selection process, and instead when you open up the piece creator, if you expand your feature tree, you can select individual surface bodies from the surface body folder. And ExactFlat will use those surface bodies as is without knitting them or making any alterations to them. Once you've created your pieces using the piece creator, we click the Convert to ExactFlat button to start the flattening process. During this process, ExactFlat is requesting a mesh from SolidWorks, and it is doing the first initial unoptimized flattening of that mesh. Part of this process is material selection. And ExactFlat uses the actual mechanical properties of the material, so it's important to choose a material close to the material you are working with. If you don't have a material close to the material you will be using during construction, then ExactFlat does partner with a university or different institutions that can actually measure the mechanical properties of the material and send you back a report which you can then use to add your own materials to your ExactFlat database. Once you've selected material, click OK, and the flattening process will finish. At this point, we can switch over to our pattern view. We can identify the pattern view from the grid that's displayed on the pattern environment. Not only do we have a grid, but we also have measurements along the top and left-hand side of the screen telling us the pattern grid divisions. As mentioned earlier, ExactFlat performs an initial unoptimized flattening of these pattern pieces. To finish the flattening process, we're going to open up the flattener window. And once in the flattener window, we can start more of the detailed steps involved with the flattening process. So, for most models, the first thing we're going to do is use the Adaptive Remesher. And what the Adaptive Remesher does is it analyzes the topology of the meshes and it creates a new mesh over top of the original. The effect of this is a new mesh with a reduced vertex and triangle count and simplified polygons. So the old mesh, if we click the broom icon here, we can restore the original mesh. When we look at the original mesh, we can see that we have a wide range of size and shapes of triangles. ranging from more equilateral triangles such as this one to more high aspect ratio triangles such as this skinny one right here. When we run the Adaptive Remesher on this, it retopologizes the mesh and tries to make all the triangles more or less equilateral. And when we do have a change in size of triangles, the change is very gradual. So for this piece over here, we can see we have large triangles here, and there's a gradual change in size of the triangles all the way to the corner here where we have smaller triangles. These meshes are ideal for ExactFlat, and they actually reduce the amount of time required to optimize your patterns, and they improve the quality and accuracy of the pattern by allowing ExactFlat to finish the optimization process. Once we have adaptively remeshed, we can then optimize our pattern. This is the second stage of the flattening process. And this uses the mechanical properties of the material to produce the best flat pattern possible. So the optimization process is quite quick. We're finished the first 5 pieces and waiting for the remaining 3 to finish, and they should be done shortly. So when we're looking at our mesh here, we can see that the color or strain analysis of the 3D mesh is actually changing. This is indicating the quality or accuracy of the pattern has improved. And when we look at the color, white indicates 0% strain, cyan or blue indicates up to 5% strain, yellow is up, green is up to 10%, yellow is up to 15%, and red is 20% or more. So when we look at the color here, the more pronounced the color is, the more vibrant the color, the more strain we have. For this mesh here, we've got predominantly white and a little bit of light cyan, so that's indicating we've got fairly low strain on here. So color is the primary indicator for how accurate the pattern is. Another way to tell or measure the accuracy of the pattern would be to compare the actual edge lengths on the 2D pattern view. So if we click OK here, we will accept our pattern, and we will go back to our 2D pattern viewport, and using comparing our 2D pattern against our 3D pattern is another way we can measure accuracy of the pattern. So we'll notice that we have the old shapes here. ExactFlat is currently in the process of updating the shape, and once it's finished, our shapes have been updated. So all of these shapes are represented by planar surfaces, which are driven by 2D sketches created by ExactFlat. So you can modify the shape of the pattern piece at any point in time if you wish, so long as you don't add or remove sketch segments. It's perfectly fine to modify the sketch segment shape and layout, so long as afterwards you click the update button. That will update the markers to reflect your edits. So when we compare the accuracy, the first method is to consider the color of the model in the flattener viewport. The more towards white your colors are, the less strain you have. And the strain progresses up to 20% or more through white being 0% strain to cyan, green, yellow, and red. So that's the primary indicator for the accuracy or quality of your pattern. The second way to measure the accuracy or quality of your pattern would be to compare either the surface area of your pattern against the surface area of your 3D model, or you can compare individual edge lengths to the 3D model as well. So for this piece here, if we select this piece, you can click on the Evaluate Command Manager. There is a measure tool in there, and using the measure tool, you can measure the surface area of the pieces, and you can also measure the perimeter length or the individual edge lengths of the different pieces as well. After we have flattened, it is usually very helpful to arrange your pattern. So using the ExactFlat Move Pieces tool, this tool allows you to simply and easily drag and drop your pattern pieces, so we can simply drag and drop that, move it to a location. We can also easily rotate it just by dragging our mouse here, so we can rotate the piece so it's more or less horizontal, or we can use the alignment tools. So for this one, I'll do an alignment, horizontal alignment, and our selected edge, we're going to tell the tool that it's going to be a bottom edge, so we can click and hold on one of these edges here, and it's going to automatically align this piece so my selection point is perfectly horizontal. Because of the way this pattern is formed, because there's also a vertex right in the middle there, this tool does not work the greatest for this kind of alignment. So we're going to go back to our original rotation here, and we're just going to eyeball this. So that's looking a lot better right there. We can also use the Find tool to help us find neighboring pattern pieces. So using this tool, we're going to select an offset here. We're going to change our offset to about 20 millimeters. And now what we can do is we can just click and hold on an edge here, and it's going to find the neighboring pattern piece for us. In this case, 20 millimeters is not enough of an offset, so we're going to change this to about 50 millimeters, and we will use the tool again. For the purpose of this demo, we're just going to increase this to 100 millimeters so we have very good separation so we can see between our pieces. So we can go ahead and we can repeat this process for all the other edges here, and we can very quickly and very easily rebuild our pattern. So once we're done with the Move tool, we can close it by clicking the OK button. And at this point, we are ready to start our patterning process. From here, we will go ahead, we will start to add seams. So we can do this using the Seam tool. The easiest way to use the Seam tool is to open up the Seam PMP, and once it's open, we can start selecting edges. It is best to select edges with the methodology and ideology that these the edges selected represent a single sewing operation. So while it is possible to simply rectangle select everything here, you wouldn't sew this seat together in one single operation. You would sew, for instance, these two pieces together, then you would cut the line, then you would sew these next two pieces together, you would then cut the thread, and you would sew the whole seat together using multiple operations. So when creating your seams with ExactFlat, it is best to follow that methodology as well. So for this seam here, I would select this edge here, and I would continue our sewing operation with this edge, and finally I would select this edge here, and all three of these edges would represent a single sewing operation. You'll notice as I was selecting these edges, the neighboring edges were automatically selected for us. So ExactFlat automatically finds and selects the neighboring pattern pieces and applies the exact same seam to those pieces. If we zoom in, we can also see that we have a seam allowance that was automatically created. So we can preview the seam allowance with ExactFlat as well. Another thing we're going to notice is that we have a green dot here at our starting point and a red dot over here, and these dots indicate the starting and ending locations of the seam. So we can use these dots to indicate the relative direction of the seam. One thing that may happen is that on the right hand side you may have the start down here and the stop up here, but on the neighboring piece our start may be indicated up here and our ending point may be indicated down here. If this happens, we can simply come down here and we can flip the orientation of an edge, and this allows us to automatically and very quickly flip the orientation that an edge or a seam is sewn together. So the flip edges allows you to flip individual edges, and then we also have a reverse direction which reverses the direction or orientation of the entire seam. So now what we see is we have our starting point up here, our ending point up here, and then over here we have our starting point up here and an ending point down here. So we can just reverse the direction, and that reverses the direction of the edge for us. We can also pre-select our edges, so this is often faster when we're working with quite a few edges and have quite a few seams in our document. We can pre-select all our edges, and then when we open up the Seam PMP, ExactFlat's going to automatically create the seam for us. So in this case, the start and stop are both in the same orientation, so we don't have to worry about the orientation. Also in the seam PMP, we can change the seam type. So this is the amount of additional material that is going to be applied to your seams. So we have, by default, the ExactFlat database comes with 6 mil, 8 mil, 10 mil, and a couple others here. The contents of this list are all manageable and can be changed using the ExactFlat database manager. So you can add or modify existing seams, or you can remove unused or unneeded seams using the ExactFlat database manager. As we change our seam type, we can see the preview is automatically updating for us as well. Part of our seam PMP is our notch chain tool. So this is an optional tool that allows us to add alignment markings or notches along the length of the seam. When turned on, we can create notches either by specifying a count or spacing. And we also have a number of different notches that come default with ExactFlat. As with many of the items in ExactFlat, the notches available in this list are, you can configure and modify them using the ExactFlat database manager. So if you don't see the exact notch type that you require, you can add it using the ExactFlat database manager. For this, we're going to go ahead and select a 1/4 inch D notch, and we're going to go ahead and click OK. So right now, our notch chain tool is configured to add a specific number of notches. We're going to add 3 notches, and it's going to space those notches evenly along the length of the seam. So if we zoom in, we can see that we have our T notches here. And it's added the notches to both the right and left hand side of the seam. If you want individual notches, you can place individual notches on the pattern. These apply only to a single side of the seam, and the side that they're going to apply on is controlled by the primary edge selection. So in this case, we selected these edges here. So if I were to add a manual seam, or a manual notch, it would appear on this side of the seam. We do have another tool for adding precision notches to both sides of the seam. It is our notches tool, and we will have a look at that a little later. Lastly, we have our edge labels tool. This allows you to apply labels to edges. So if we wanted to add a label indicating which 2 pieces are being sewn together, we can do that either manually through the seam PMP or using the ExactFlat option. So we can configure a default template that is applied to every single seam that is created. So if you always want labels applied to your seams, you can configure that using the ExactFlat options. The important things in this dialog is we need to choose a label type. With the label type of edge type, it's going to tell you which type of seam was created. In this case, it would be 8mm, that would be your label. Using the pieces label, we can actually create labels using the piece names that are defined using the ExactFlat piece creator, or by renaming the pieces in the feature tree. With this label here, the label is going to be comprised of 2 parts. It's going to be the current piece that the label is applied to, and then there's going to be a slash, and then there's going to be the piece that the current piece sews to. So for these 2 pieces here, if this piece is piece A and this piece is piece B, the label in this edge would be A/B, and the label over here in this seam would be B/A. Lastly, we have our edge name label. Each seam type does allow you to apply a custom name to it, and when we're using the edge names label type, the label will be comprised of the edge name or seam name that was given to the seam using seam PMP. For this demo, we're going to go ahead and use the pieces label. I'm going to go ahead and click OK. We can specify the alignment of the label. So the label is either going to start at the center of the seam, or it's going to start at the start of the seam, or it's going to be placed at the end of the seam. And beyond that, we can specify tangent offsets. So the tangent offset is an offset along the seam from the placement. And we can also specify a normal offset. So the normal offset controls how far into the piece the label is going to be placed. We can also specify limiting controls on the label. So if we specify a minimum length, then this label is only going to be placed on a seam that meets the minimum length. So in this case, if we specify 1,000 millimeters, this label is only going to be placed on seams that are at least 1,000 millimeters in length. Similarly, we have a maximum length which controls the longest seam possible for this label. So again, if we set this to 1,000 millimeters, then this label is only going to be placed on pieces with a seam length of at most 1,000 millimeters. So once you've configured your label parameters, we can click OK. And the label will be placed on our seam for us. In this case, it placed the label at the center of the seam. So on the right hand side, we have ExactFlat 1 / ExactFlat 2. And over here on the left, we have ExactFlat 2 / ExactFlat 1. This label is telling us that piece ExactFlat 1, so is the piece ExactFlat 2. Once we are done configuring our seam, we can click the check mark to close and accept the seam. If we are pre-selecting our edges, it is very important that we click somewhere in the white space of the pattern viewport to deselect the existing edge selection. If we don't do this, if any of these edges remain selected and we click on the seam PMP again, the seam PMP will be opened up in edit mode where we can modify the seam. So in the case of trying to create new seams, this is not ideal. You'd be probably adding additional edges to this seam. However, if you do need to make a change to your seam type, then you can pre-select an edge and click the seam PMP button, and that will open up the PMP and allow you to modify it. So for instance, we can change our seam type to 10 millimeters. Add additional material here. We can see that the notches are all updated as well as the labels. Then we can click OK to accept our changes. Once again, we'll click the white space to remove our selection, and we'll go ahead, we'll pre-select these edges over here. So just holding Shift on my keyboard, I'm selecting multiple edges, and now I'm going to go ahead and open up the seam PMP. It's also important to note that your edges should be selected in the order that they will be sewn together. So in this case, this seam is comprised of 3 edges. So when I'm doing my selections, I'm selecting this one first, then this edge, and then finally this edge. If we select them out of order, ExactFlat does take into consideration the order that edges are selected. ExactFlat will actually create a jumper from one edge to another, and internally ExactFlat is going to believe that this piece will actually physically be picked up and moved, and the piece will be sewn as the edges are selected. So this has implications for your notches and notch chains. Normally you would expect them to be placed evenly across the seam. However, if you select your edges out of order, you're going to start to notice that the notches don't look right. They are still being placed evenly across the seam, but they're being placed evenly across the seam according to your edges, the order that the edges were selected. So visually, you're going to notice that none of your notches really line up. So it's important that you select your edges in the order that they're going to be sewn together. We'll also notice that ExactFlat has remembered our seam type, join 10 millimeter, and our notch chain parameters. So every time we open up the seam PMP, it's going to automatically pre-populate our parameters with the selections that were used at the last time the seam PMP was opened. So we'll quickly go ahead and we'll finish up our seams here. We'll select this edge, seam. Once again, we're going to have a 10 millimeter join here. For this one here, we're going to go ahead, we're going to modify this seam again. And we're going to add one more edge. We're going to add this edge down here to it. So we're going to go ahead, we're just going to add this to the list, and ExactFlat's going to automatically add that edge here. We'll also notice that we have that jumper indicating that the seam continues across the division here. So we'll go ahead and we'll accept that. We will pre-select these two pieces here, open up our CMPMP, and ExactFlat's going to automatically find our neighboring pieces for us. And lastly, we will select our edges on this piece up here. And we will open up our CMPMP, and ExactFlat's going to automatically find all the neighboring pieces for us. For this piece, we may want to change the number of notches in our notch chain, so we're going to scroll down here, and we will change the number of notches to 5. Now we have 5 notches spread out evenly across this piece. We can also apply hems and bound edges and raw edges to our piece, and they're very similar to seams. This PMP looks identical in all cases. The only difference is hems and bound edges and raw edges, they don't have neighboring or joined sides to them, whereas seam, we have a right and a left hand side of the seam. Hems are single-sided operations, so as we select edges for a hem here, we don't have a neighboring piece that's going to be automatically selected for us with the hem. So for this piece here, we might want to add a larger hem to accommodate any kind of reinforcement that may be applied on there. So we'll go ahead and create our hem there. We're going to turn off our notch chain. And we'll go ahead and click OK. Again, we want to consider our hems as single sewing operations. We don't want to just rectangle select everything and apply a hem to it. So we're creating our hems one edge at a time. And just like with our seams, our hem PMP automatically remembers the settings we last used. So we've automatically have our 12mm hem applied, and we don't have any notch chain applied. So we're just going to go ahead and click OK. And lastly, we'll apply a hem over here. And then we'll finish up with the front. ExactFlat also has our manual notch tool. So if we need a notch placed on a piece in a precise location, we can do that using our notches tool. So we will go ahead, and the way this tool works is we create a 2D sketch on the pattern piece, and then we just use point entities to represent the location of the notches. So we'll create a point there right on the edge of the piece, and we'll create one more right there. So we have 3 points along the edge of this piece here. We'll close our sketch, and now we can use the ExactFlat notches tool to apply these points or convert these points to actual notches. The benefit of this is you can actually dimension the location of the points using the sketching tools, and then automatically convert these points into notches using ExactFlat. So we will create 1/4 inch V notches from these points. So we'll go ahead and we'll click OK. And these points have now been converted into notches. Once we've finished our patterning, we can go ahead and we can create a DXF of the pattern. To do this, we will click the View Markers button to open up the ExactFlat Marker Manager. Once open, we can see a preview of the pattern. We are now in the manual nesting interface. So once here, we can manually move all our pieces around on the document, and we can rotate them by holding the right mouse button as well. If the piece appears orange, it's indicating that there is either a collision or the piece is trying to be placed off the marker, and if we lift our mouse button, it's going to snap the piece back into location. If it is intentional that we want our piece to intersect or be placed off the marker, we can simply press escape on the keyboard and drop the piece in place. The pieces that are being affected by this piece will also be highlighted red, indicating that these pieces intersect one another. If we want ExactFlat to automatically nest and pack these pieces on the marker, then we do have a couple other options as well. One of them is our placement method that is being used to place these pieces on the marker. By default, ExactFlat will apply what's called box nesting to the pieces. Due to my settings, I have a different placement method selected here. So if we look at the marker settings, we can click the cog icon down here. We can open up the different marker placement options, and as I mentioned, I'm using a placement method called none, and with this placement method the pieces are placed on the marker as seen in the pattern viewport. If we change this to box packing, then we will see a different layout. We can click the repack button down here to repack our marker, and it's going to repack it using the box method. And with this method, it's going to try to automatically rotate the pieces so they consume as little height as possible, and then it's going to place them on the marker to try to consume as little material as possible. This method isn't considered an automatic nesting method. It can still produce waste. If you do require an automatic nesting package, then we do use Fraunhofer to provide our automatic nesting, and we can access that by clicking the nest button down here in the bottom right corner. This algorithm, or the Fraunhofer algorithm, will automatically rotate these pieces to try to find an arrangement that uses as little material as possible. So when we click the start button, it's going to start to automatically rotate and arrange these pieces to produce the most efficient nest as possible within the given constraints of the pattern pieces. Each piece has a rotation tolerance and increment associated with it, and different constraints associated with it that Fraunhofer uses to control how the pieces are rotated. We combine these different constraints into what are called lay rules, and these are accessible from the marker manager, and the lay rules themselves are associated with the different material that you'd selected during your conversion process to ExactFlat. So for instance, different lay rules, we have maybe one-way rotation, which basically disallows or no-way rotation, which disallows any kind of rotation. We may have two-way rotation that allows the piece to rotate 180 degrees. There's a four-way rotation that allows the pieces to rotate in 90-degree increments, and then there's any way, which is what we have here, which allows the pieces to rotate in any orientation. The selection of your lay rule depends entirely on your manufacturing process and the material being used. If your material has a pattern on it, such as a stripe or a plaid, you probably don't want to use any orientation. That's not going to be visually appealing. You're probably going to want to select a 180-degree rotation. That way, when you sew your part together, all your pieces, all the stripes and angles line up on your pattern piece. Once the nesting has finished, we can either click the accept button to accept the results of Fraunhofer, or we can click the remove button to reject the results and go back to our original marker. So in this case, we're going to click accept, and we're going to close the automatic nesting module. We can change the lay rules and many of the different configuration options of the markers by clicking the edit button up here. And this is going to open up the different properties for this markers. As mentioned earlier, we have different lay rules, and these are just different groupings for the different constraints available for use with ExactFlat. Two-way rotation allows 180-degree rotation. Any way allows any rotation. One way is no rotation allowed at all. Four-way is 90-degree rotation, and then flow poly is just a special different layer rule that we created. And using the database manager, you can modify, create, and remove any of these layer rules that need to be placed. Our placement groups are only applicable to automatic nesting, and specifically our ExactFlat standalone. So if we are nesting the markers from multiple parts together, our placement groups allow us to define how the pieces from different parts are all nested together. Finally, we have our material options here, and this allows us to define the width and height of our material being used. And again, all these values here for material lay rule, they're all stored in the database, so we can modify these values in the ExactFlat database manager. Using this control, we can override the defaults in the database if we need to. So using this, we can turn on or off whether we're using a bound surface. So if we have very defined sheet stock, or if we're nesting on a static table, then you'd probably want to use a bound surface. That's going to define a set material width and length that we can nest onto. Whereas if you have a conveyor cut or continuous cut system, if you've got a roll of material and the table just pulls the material on as it's needed, then you'd want to turn off your bound surface, and that basically gives you an infinite length for your marker, and it's going to create a single marker for as long as necessary to cut that part. When using bound surfaces, we can also modify the width and height of the material here. So in this case, our material is about 3 meters long, which is quite high. So we might want to reduce this to 1,000 millimeters, which is 1 meter. And when we click OK, we can see that our material the dimensions are going to change, and our marker is going to automatically be repacked for us. Once we have the marker that's desirable, we can click the Export button to create a DXF. ExactFlat uses different export profiles to place different information onto a DXF with different layer names and colors. By default, ExactFlat comes with 6 different profiles. We have our ASTM profile, Autometrics, Eastman EasyCut, Gerber Cutworks, HPGL, and a standard DXF file. All these profiles can be modified using the ExactFlat database manager, so if you don't see a profile that meets your needs, then we can create a new profile that does meet all your needs using the ExactFlat database manager. So for this, we're going to click Standard DXF, and we're just going to click Export here, and this is going to allow us to save a DXF to our hard drive. So we're just going to use the default name, and now we have a DXF on our hard drive that we can then either send to our cutting table, or if we're using another program to do our patterning, we can bring it into AccuMark, or we can bring it to AutoCAD, or whatever our process is at this point, we can continue on. So that has been a brief overview of the standard ExactFlat workflow. Thank you very much for watching, and have a good day.